Assalamu alaikum wa rahmatullah. So I found this moment again special here to discuss a problem. But the problem I will just discuss here, it belongs to the physics of hydrostatics. Okay. When we talk about the physics of fluids, it's a very important thing that comes into picture, and it has great applications indeed. Okay. So let me just discuss here the problem part of this context. Like if as if it's given in a question, like we have the tube that's going to be placed inside the water. Okay, if we have the cylindrical tube, but we place a cylindrical tube inside the water, but we place it in a like that it is inverted here. Okay, let us assume that I'm just going to draw here the box. Okay, but inside the box there is a water. Okay, if I will assume here the total length of this tube is here, it is of L units, but L by 3 length of this tube possesses an ear. Okay, means 1/3 of the length of the tube. Under this length there is an ear. Okay, up to this mark there is an ear inside the tube. Okay, now in addition we are going to keep the box on the tube here. If I will just assume that I will just name this box as B, and I will just name this tube as T. Okay, we have an inverted tube inside the water. Okay, and 1/3 of the length of the tube, it consists of air. Okay, and we kept some box on the tube here. If it is given in a question, when we talk about this tube, it has a density of 2D units. Okay, now when we talk about this cylindrical tube here, it has a radius. Okay, radius of tube is given as R, but this tube is light in principle. Okay, means that the density of water is not going to change by placing the tube inside it. Okay, when we talk about the density of tube, it will be just like the density of water. Okay, as if the density of water is given as D here. Okay, D represents the density of water, but this tube, it is light in principle. Okay, and we have the box, it has a density of 2D units. If the question asks us, we need to calculate the volume of this box. How we can calculate it? But there is one more conditional, that's a very important statement given in a question, like the equilibrium of the tube inside the water, it does not change after placing the tube on placing the box P on the tube. Okay, means equilibrium of the tube stays inside the water. Okay, equilibrium position of the tube does not change even if we are going to place the tube on the we are going to place the box on the tube. Okay, whose density is 2 times relatively the density of water. How we can calculate the volume of the box under this particular case and all that? How we can look the problem of this type? I told you as before, there is a very important condition that's given in a question, like when we talk about the equilibrium. Okay, the moment when we are going to place or we are going to keep the box on the tube, its equilibrium does not change. Okay, its position of equilibrium does not change. So its equilibrium is going to be unaffected while on placing the box on the tube. Okay, what that exactly means? That means that simply, like when we talk about the weight of this tube and the weight of this box, it will be balanced by the buoyant force due to the tube and due to the box. Okay, this is only if and only if possible when we talk about when we are just look for how exactly the equilibrium of this box will be maintained inside the water, even if we are going to place the box whose density is given. Okay, it means unlike when we talk about the net weight will be equal to the buoyant force. Okay, buoyant force. Why so? Because equilibrium stays here. Equilibrium of the tube stays here in its position in case if we are going to place, I mean, the box whose density is 2D units, okay. This is a condition that's as a consequence of the, I mean, equilibrium that stays here, okay. So I hope that you are getting it, because it's a conditional that I am going to write here from the question. Just like the equilibrium position of this tube that stays here if we are going to just place the box on the tube, okay. For that, the net weight will be the weight of tube and the weight of box. What will be the weight of tube here? Yes, it will be the mass of tube, mass of here the box, times the acceleration due to gravity plus mass of the tube times an acceleration to the gravity, okay, is equal to F of box plus F of tube, okay. If the sum of the two forces of the respective bodies will be equal to their weights, then and only then an equilibrium position will maintain here, okay. Okay, so if I write mass in terms of density, I can get, because density is defined as mass per into volume, okay, mass upon volume. So my mass will be simply rho times V, but the rho for the box it is given as 2D, okay, times, if I will assume here the volume of box is VB, this is something that I need to calculate here, as if it's a question that asks me to calculate, plus as if it's given in a question. When we talk about this tube, it is relatively light, it's light, okay. So I will do here one thing, I will just take what I can say, the density of water, okay, means that it will be D times the volume of this tube, that's equal to is pi r square. Yes, this is something where we need to be very careful whether we will take this length in consideration or this length. Look, when we talk about the weight of this tube, okay, so weight of this tube will be under, I mean, the density of the water is, it is throughout constant, okay. It is something that we just look for the first assumption while discussing the physics of fluids, okay. So the density of water is throughout constant, as if it is D, it will be D here as well, okay. So here means that the water is up to the length of this much, okay, as if tube is light in character, so this length of the tube will not contribute to the weight, okay, because weight is going to be lie up to this length. That means 2L by 3. Hope you are getting it, okay. Now I will just equate it, the buoyant force due to the two bodies here, it will be the buoyant force for a given box, that will be, yes, again, buoyant force of buoyancy, it is defined as, yes, rho GV, okay. This is an expression for the buoyant force. So here it will be the rho will be here D, okay, density of the liquid, and G will be, as if for this it will be the volume of the box, that's VB, okay, plus again DG, volume of the box, volume of the tube will be here phi r square, yes, L, okay. Yes, because when you take the box tube has here the one body, so that's why I'm just taking here whole length in consideration. Hope you are getting it. Here is VB, just like an unknown that I can just calculate here without any difficulty and all that. Look here, there is DG here comes 2VB plus, yes, DG will be here again, so it will be pi r square L by 2L by 3 is equal to DG VB plus, yes, pi r square L. DG will cancel, it will be 2VB plus pi r square 2L by 3, it will be VB plus pi r square L, okay. So 2 will be VB, it will be simply VB, and here it will be, yes, pi r square is here, and there it will be L is also present there, and it will be simply 1 minus 2 by 3, okay. This is a simple algebra here. It will be pi r square L, it will be 3 minus 2, that will be, this is the volume of box, okay? By this way, we got the expression for the volume of box, which was indeed, I mean, the question which was about how we can calculate the volume of this box, okay? That's going to be kept on the tube.